Okay, divergence of f turns out just to be partial with respect to x of what? Your x component, negative y, plus the partial with respect to y of x, both partials of 0, so your divergence is 0. Fits intuitively with the idea that that vector field is purely rotational. It doesn't stress anything, it just tends to make things rotate, right? Okay, curl of f is, and we'll write this out a little more in detail. And I will write out the details now since not everything comes out to 0. So it's a partial with respect to x times I times negative y, not times, but operating on negative yi plus xj, plus a partial with respect to y times of j times negative yi plus xj. And that equals negative partial of y with respect to x times I cross I. Of course, we know that's going to be 0. Okay? Plus partial of x with respect to x times I cross j, which is not going to be 0. That's going to be k, right? And that's going to give us the k vector. And then it's going to be plus well, actually be minus partial with respect to y. Of y. And then that's j times j cross I plus the partial of x with respect to y multiplied by j cross j. Okay? Now, I cross I is 0 anyway, j cross j is 0 anyway, but so are the partials in this case. We end up with just 1 times I cross j minus 1 times j cross I, which equals k minus negative k, which is 2k. Okay? So, what we have divergence of 0, curl is 2k. And you can think of that in terms of what we're doing in physics right now, because it's a perfectly good analogy. Again, if these are force vectors acting around here, this is going to give you something.
Oh, it's not negative 2k, it's positive 2k.
Positive 2k.
Yeah. You're talking about negative 2k in the previous page.
Well, we had a negative of negative k, right?
Yeah.
Because we had 1 times I cross j. I cross j is k. We had a negative 1 times j cross I. Well,
Yeah.
j cross I is negative k. J cross I. Okay? So it is 2k. And again, to make the analogy, if these are forces, that's going to tend to make this thing accelerate in this direction. Is that the positive or negative direction of rotation?
Positive.
Yeah, and you did it with your right hand, okay? Because of, yeah, x, y, z, x, y, z, right? Cross product here, right? And of course the right-hand rule. You know, in your direction, curl in the direction of your torque. Of course your torque is in this direction, right? Okay, anyhow, it's very clear and very consistent with what we do with a little bit of mechanics here, right? And now if you do it with fluid dynamics, if these are forces acting on your fluid, the fluid's going to tend to rotate about the center, right? Fluid's going to be rotational. It's going to be a rotational field. Non-zero curl means we have a rotational field, okay? Here, divergence is 2. You could kind of think of that mechanically as the total stress tending to pull this thing apart, okay? Or you can think of it as, if you got a positive charge here, these would be the directions, at least, of forces and positive charges, although this wouldn't be a good model because it increases with distance instead of decreasing, right? As we mentioned, okay? We still get kind of the idea that you got a positive divergence, which is pushing things away from the origin, okay? And we have the curl equals 0, no rotation, okay?